Hello, hello. Welcome, everybody. It's really great to see you here. Please drop your hellos in the chat. It's great to see everyone here on a Friday afternoon. Thank you for making the effort to come along. I'm just going to invite our speakers from today up to the stage to get everything prepped. But hello to everyone, Andrew, Nestor, GM, what up, what up? Good to see you all. Hello.
I almost didn't make it, man. That the CAPTCHA, it got me. I failed it like 3 times, I guess.
Oh. What did you have to spot? What did you
I had
nearly
to
slip
pick
up
cars.
on?
It wasn't even that hard. It's just sometimes they don't know that it's a car, I guess.
You have that awkward situation where sometimes it overlaps by like 1 pixel
A
as well.
tiny little amount. Yeah, I think that's what got
Why
me.
does he do that?
Hello, hello. Right. Well, would you like to share your slides? We'll just give it another
let
minute.
me do that
I can see
right
some
away.
people coming in. Hath, maybe you want to start uploading your video as well.
I think so. My deck was already uploaded from before.
Nice and easy.
It might already just be uploaded. So.
Beautiful. Awesome. Well, everybody is just joining in. We'll give it another 10 seconds or so just to let a few latecomers come.
The video is there.
Perfect.
Look at us. Nice. We're so prepared. We're so prepared.
Can we throw a pull up, or only you can throw a pull up?
It might only be me if you cannot see the poll screen. I assume you can't.
It says no polls yet. Team members can send you polls here. Your answers won't be shared with other attendees.
Yeah, sorry, it's just me then. I can share a poll if it's something I can easily type in quickly.
I would like to know what everybody's favorite programming language is.
Ooh, okay.
And maybe put Solidity, Rust, Python, and JavaScript, and maybe other.
Awesome, great. Well, I guess we can start there then. We are finally set up, which is great. But yeah, thank you very much to the team for coming along today and delivering this workshop. Thank you to all of our participants for coming along too on a Friday afternoon, choosing to spend your time with us. It's great to see so many of you saying hello in the chat. And as we've just set up, please do select the polls. Select your favorite programming language. For those who haven't seen it, it should be on the bottom right. You should see 3 bars and you can click there. But I think that's enough for me. I've been chatting away. Hopefully we can get the results of the poll in a minute or two. But otherwise, I'll hand straight over to the Versatus team. Thank you for joining us. And yeah, please take it away.
Thanks, guys. Excited to do this. Excited for everybody to be here. Just as a little bit of an introduction to Versatus, Versatus is building a decentralized cloud platform. So we're building an unstoppable cloud. We're focused on building products on top of EigenLayer, which hence, I think probably most of the workshops that you're doing these next couple of weeks are focused on that. We are building one rollup, and we're also building an AVS. And so we'll talk a little bit more about the AVS towards the end. The majority of this workshop is going to be focused on our rollup, which is called LASR. And we'll get into the why behind that. But just as a sort of quick intro to myself, my name's Andrew. I decided to put my Twitter handle in here, so hopefully you guys will go and follow me. So that's the name that you're seeing underneath my screen. I've been a software engineer for 14 years professionally, mostly focused on machine learning, AI, and then in the later part of my career prior to starting Versatus, I was a distributed systems engineer, so a lot of experience across those 3 disciplines. Been programming since I was 14. It's about 20 years now. I'm a lot older than I look when I'm shaved. If I'm not shaved, I look a lot older than I am. Yeah, that's a little introduction to me. Hath, do you want to give a little introduction to yourself and maybe Gloria? It's been 2-3 minutes. Just introducing yourselves before we get started.
All right. What's up, guys? My name is Andrew. I'm from Vermont, and I used to be really into skiing. I was like a professional skier, and I'd hit really, really big jumps. And then I went to college, and I was like, holy shit, electronic music is so awesome. So then I started a band. So then we went and toured around the country, and because EDM's like you're writing software with computer or music with computers, and music is math. I found that I really enjoyed computers and working on computers. That was probably like 12 years ago. And then I went and worked at Comcast for like 4 or 5 years as a systems architect. Helped them build like an internal AWS effectively, and then did a little startup, and that's where I met Andrew, and the rest is history.
Hey everyone, I'm Gloria. I lead developer relations at Versatus. My hobbies include talking to developers and also long walks on the beach. And I'm really looking forward to hearing everyone's feedbacks, especially because we're a very developer-centric project and we want to be the best resource in the Web3 space for builders like you guys.
Absolutely. I think that's probably the perfect place to kick off. So we like to think of ourselves as Web3 Unchained, and you know, when we start talking about our AVS, the little block bracket in the middle will make a little bit more sense. We believe that blockchains are a really, really important tool for a really, really small subset of problems, but that those problems are really important problems, and they need to be solved, and blockchains solve them really, really well. But there's a whole host of things beyond the blockchain that we think also benefit from verifiability, decentralization, and censorship resistance. And so we'll touch on some of those themes throughout the workshop. Primarily, this workshop is about LASR, as I mentioned. LASR is our roll-up. It is called LASR because it is a language-agnostic, stateless roll-up. So what does that mean? Basically, it means that you can program and you can build smart contracts in any programming language. Starting with JavaScript, we'll be expanding to Python, Go, Rust, C, C++, and eventually other languages, as well as including some Web3 languages. So why is that important? Well, there's about 25 million developers in the world. There's only about 25,000 building in Web3. And so, you know, part of the problem that we run into in this space is we got a lot of people in the space who are really, really smart, often too smart for their own good. And so they get very creative and they come up with new ways of doing things. And oftentimes you don't actually need new ways of doing things. So, you know, we wanted to simplify things while still retaining a lot of flexibility and still retaining a high degree of security. And it's our belief that the simpler it is, the easier it is for you to build secure smart contracts and as a result, secure dApps. The current Web3 developer experience is not great, and you'll hear this over and over again. I know Encode Club has really built a business around the fact that people want to learn it, but it kind of is a steep learning curve. And so you need boot camps, you need structured learning programs, you need a way to break into the space, you need to get your first job. It's a lot, and opportunity cost as it is, a lot of people just choose to stay in Web 2. They make a good living building in Web 2. There's not as many jobs today as there once was. People have been getting laid off and stuff, and that's an opportunity for Web3 to kind of present its value proposition to those developers. But there's a lot of money to be made just by being a Web2 developer. So why go and learn a new skill, particularly a skill that at least in the Western world is still viewed as very, very niche. And we often hear over and over again, like, when do the next billion users come? When do the next, like, how do we acquire the first billion users in Web3? And the answer to that is really, really simple. It's after we acquire the first million developers. You need developers to build applications. Those applications are what users are going to use. If there's nothing for the users to use, the users are just simply never going to come. So that's one part of it. The other part of it is that currently really only a small component of the application stack is even decentralized at all. And that's the smart contract. The rest of your application, your front end, off-chain components at your backend. If you have databases, if you rely on oracles, a lot of times those oracles are actually centralized or at least hosted in amongst a cloud provider. There's lots of aspects of Web3 that are still very much reliant on the Web2 backbones and infrastructure. And so what we're building, we like to think of as like the universal dApp engine. Another way to put it is like an integrated cloud for unstoppable apps. We think we're the perfect marriage between cloud and blockchain. You get the best of both worlds. You get scale, flexibility, familiarity. You also get decentralization, trustlessness, verifiability, which you can't have trustlessness without verifiability, fault tolerance. All of those things are very important. Now, there obviously clearly are some trade-offs. There's trade-offs in everything. For the majority of what we do, having redundancy across a wide network of node operators is not necessary. You need some redundancy, but you don't need the level of redundancy that blockchain offers for most of what we do. So with that, we'll jump into LASR. What is LASR? As I mentioned earlier, it's the language agnostic stateless rollup. Allows you to build smart contracts in the languages that you already know and with the programming tools that you already love. So we want to meet developers where they already are. We don't want to require developers, Encode Club. We don't want to require developers to have to go and learn new skills. We want them to come and be able to start building in Web3 day one. And that's a big ask. But we know that there's demand for this. And the reason we know there's demand for this is for a couple of reasons. A, if you scour the web, you will find lots of demand for this. The other reason is that we actually commissioned a survey. And what we found, the survey was of 1,000 US-based full stack and backend developers. So this would be your closest comp in Web2 to your typical smart contract or blockchain developer. And 40% of those developers said that if they could use the skill set they already had, but build in Web3, they would already be doing it. Another 38% said they were somewhat likely to start doing it. So, those are ones that are on the fence, but 40% of a 12.5 million person market is a lot. And so we want to be able to capture that, bring them in, have them bring their ideas into the space, start new businesses, start new dApps, and contribute to the ecosystem. One of the really cool aspects about LASR, besides the fact that you can build smart contracts in any language, is that we have a very, very simple framework. And these two things go hand in hand. So instead of having like a virtual machine with, I think Ethereum has like 78 ops and then they're doubled up. So there's like 156 operations or something like that in the EVM. Might be a little less than that. Don't quote me on that. But it's something along those lines. Instead of that, we have 4 simple operations. And if you come from Web2, you will see a common theme here. We have create, update, transfer, and burn. That's it. And you can package up to 1,000 of these instructions into a single smart contract call. So you can do a lot with very little, and they're very, very flexible. Obviously, you can create new supply of a token. You can create new token IDs for NFTs. You can create a new data that can be stored in a token. There's all sorts of different things you can do with the create instruction. Update, you can go in and alter those tokens. And you'll hear the word token a lot throughout the presentation because in LASR, everything's a token. Everything's a token. Whether it's data or actual financial assets, everything is a token. Transfer obviously is pretty self-explanatory, as is burn. And so with those 4 simple instructions, you can basically accomplish everything that you would be able to accomplish in the EVM, the Move VM, the Solana VM, but you only have to remember 4 instructions, which is really, really nice. You return those instructions from your programs, which behave very akin to sort of like Lambda style stateless functions. And with those 4 instructions, you can actually read them because they're returned in JSON. And so with that said, I think we'll pause here. We're going to hand it off to Hath to do a LASR demo. So he's going to share his screen and he's going to walk you through something that he's been working on that we think is a really, really cool product, a great showcase, but also on its own a standalone product. And he's going to give you a little bit of a lay of the land of how you build a LASR program and deploy a LASR program, as well as what it looks like live after you've built it.
All right. Nice. Thanks, Andrew. What's up, guys? I'm Andrew as well. And what we're going to be building today, or at least showing you guys what we built, is chess. And this chess game is peer-to-peer. It allows you to bet and like place a wager on a game, and then after you do that, you'll play peer-to-peer on chain, and it's live. So it's like using WebSockets and front end to broadcast the moves between any of the browsers, and also anyone who wants to watch, which has like been something that I really enjoy, is watching people play chess on LASR. So without further ado, let's just go ahead. We'll hop in here and make 1,000 verse game. So this is going to create the game and then redirect us to the actual the chessboard. And as you'll see down here, this popped up. This is the game that now I'm going to join with this browser. And so both of these browsers, one's a Brave browser, one's a Chrome browser, and they both have our wallet extension installed. And then and so obviously they have different addresses. And obviously this one has a lot of verse. This guy doesn't have as much verse. This is a 2,000 verse game. And so let's just dive in. So I've been like testing this thing, so I know how to lose really quickly. So don't do this when you're playing for real. This is the fastest way to lose. So as you'll see down here, what's happening is we're effectively streaming the changes and polling the LASR network for updates, and then streaming those to all of the people that are connected. And you'll see the number of people down here. And then so cool. We just did that, and now we're going to do this. And then up top, that'll update. There we go. And then we go to here. We're going to do that. And then this guy down here is like, oh my God, what an idiot. So then he moves here. We approve that signature. We have now we have won this game, and then you'll see up here that it has broadcasted the game state to the other user, and the game is over. So we'll return to lobby. And then now what we can do is kind of hop into what's going on underneath the cover. So we're going to go left.
Well, first point out that the winnings get transferred as well, right? That's an important part of it.
Yes, exactly. So let's see here. Right top, right quarter. Yeah, so there might have been a small bug in my transfer, but it took my 1,000. I don't know that it actually transferred though. As you can see here, though, that it did update this. So there is probably a bug. We've been kind of working all night on all this stuff just to make it ready for y'all. So so this is the entirety of the LASR chess program. As you'll see here, it's only 270 lines long, minus 20. So it's about 250 lines long. And like one of the best parts about developing in LASR is you get to develop and use all of the packages that you're accustomed to in your Web 2 day-to-day lives, but in Web 3. So in this case, what we'll do is you'll see here, I'm using this library called chess.js, which effectively allows us to run chess in a headless manner. And all you need to do is pass in this thing called a fen. A fen is a string which denotes the current game state. So as the game continues to progress, this fen is going to change. This fen then gets streamed to the front end, and then we're using React Chessboard to interact with and display that chess game. And then so when we move a piece, we're triggering a call to the program and then signing and broadcasting, which is then coming into to the program, and these are the methods by which we play the game. So the first thing I'm going to dive into here is create. Every single LASR program that we make, so the deployment process is, and we can dive into the command line interface here in a second, but the deployment process will take, in TypeScript's case, it'll transpile your TypeScript into a single executable JavaScript file using Webpack. And then it takes that it's not really a bundle, but it takes that single file and then it broadcasts it up to LASR, where it gets registered into IPFS. Once it's in IPFS, we then register that CID with LASR. And then the final step is to call create, which effectively lets us set the metadata and the data fields inside the program. So let's just take a look here real quick. Here's our metadata fields that we're setting, and we have some nice functions here which make it pretty easy to update a program's metadata and a program's data field. And a good way of thinking about, especially the data field, is that a data field is like, it's like a key value store that that you can literally store anything in. As long as it's key and then string, as long as you can stringify whatever it is that you're trying to store, then you literally can put anything in here. And then so we have some sweet, as I said, some sweet functions here that'll make it really easy. And what these functions are doing is they're just returning instructions. If you'll remember back to what Andrew was saying, the instructions, you can have up to 1,000 in this array. And when these instructions are run by the protocol, it's atomic. So if 999 of these instructions work, but one of them doesn't, then the transaction won't. It'll fail. So you can keep that in your back pocket and keep that in mind when you're building out your guys' programs. Cool. So this is the create. We have a token distribution, which in the case of chess will distribute 100 chess. They're effectively NFTs to the main program. And then during registration, the user then, when they register, they're effectively minting a chess NFT, which allows them to play the game. So there's our create. And then we'll dive into register user. So when someone comes and wants to play chess, they need to register. So what we do is we take in a username and an address, and then we parse the account data. So the account data, we have access inside of the compute inputs. We have access to the main program's account data, which allows us to reference and then also update current data. So as you'll see here, I can go and get the current users that exist in this main program, and then add a new key value pair here, which is just address and username. So then this way I can call the main program and then get a list of all of the users. So this is register. And remember, I mean, these functions here, literally just this right here, they return instructions, which we then pass into this instructions array, and we return that. And this right here will then update the main program's data field with the new registrar or the newly registered person. So we've registered the user, and then now what we want to do is we want to make a new game. When someone registers, quickly just popping back over here, this right here is effectively us transferring the NFT into that person's account. So we're taking it from the program ID, because during the create step, we've initialized a certain number of chess NFTs, and we're sending it to that address. The token address is itself, and then the token IDs, which this right here brings in, this function right here will bring in all of the available token IDs from this main program. So then up in new game, when we trigger a new game, we create a new game ID. We take a new game then, which is up here. This is just a blank board with 4 rows of 8 spaces in the middle. And we're just going to town right here in the data field for the user that created the game's token. So for every registered person, they get an NFT, a chess NFT. That chess NFT is where that user's games are going to be stored. So in this case, what we're doing is we're updating the token data. We passed in the account address from the from field, which comes in from our transaction. The program address is this, meaning we're talking about this program address associated with this account. And then we're setting these KVPs, these key value pairs. One thing that I've found in like building all this stuff is you don't really want to get too nested with your data, because it can kind of get a little bit hairy eventually. So something that I've found is to make keys that are very very specific and tell you exactly what's going on, but they're also unique. But also by keeping the data schema flat in the data or in the data field. We also have a bunch of methods in here or inside this SDK which allow us to like remove fields, right? We can extend fields, we can replace fields, etc. So like if you had a nested object inside one of these as a value for one of these keys, it's a little bit more tricky to work with. But on the roadmap, we're looking at introducing all sorts of helpers that allow us to manage, arrays, right? Being able to pop things off of array or push things into an array. Yeah, but again, you guys are early, so as you start getting into it and find some pain points, I mean, just join the Discord and come on in and like let's discuss, because we're just trying to make it. We're just trying to build something that is really, really easy to use, fun to use, and is just, allows people to move really quickly. Like I said, this whole chess thing is 250 lines long, right? I mean, this right here, I don't know how big this library is, but because we're using JavaScript and Webpack right now to pilot or compile this or transpile this all together, these don't have to be very long, right? We can use a lot of the same libraries that we're used to using in Web 2. Okay, cool. So we create a new game. We're updating the person who's creating the new game's token data with these fields, right? The fen, the from, it's initialized. That's our state. It's got the wager, and then also down here, when we create a new game, we take the wager. We're transferring that amount of verse in this case from the person who's calling from to this. So now this main program is effectively like an escrow. Cool. So we have a new game, and then we go and we accept the game. The exception comes in from, or the person who accepts comes from the UI. We'll pass in the game ID, address 1, meaning we're telling, hey, program, look in this guy's account to find this game, and then also the wager. And then so here we're updating the token data. We're changing the state, which is, remember, address 1 is where that token exists. We're changing the game state. And then we're also adding address 2, which is the new user that just came in, which is the from, right? Cool. Then we transfer from the people who just called to this main program. And just like that, we can start. So after you accept the game, in the front end, you would then see the game board come up, as you just saw a second ago. And then it's really, this is the meat and the potatoes right here. Literally the entirety of the chess logic exists in here, which is tiny. Remember, we're using chess.js, and because we can do that, we can keep our product, our program extremely small and concise. So in this case, we're taking the fen, which gets passed in during the move. We take the fen, and then we also pass in a move, which is a standard. It goes from this square to this square, and this chess program just understands these fen strings and how they work and what's legal and what's illegal. So we take the fen, we initialize the chess game, we move it based on this move object here. We grab a date now, so we're updating the updated at. We then test to see if the game is over. If the game is over, then we go ahead and we transfer from this, meaning the main program, to the person who made the call, because the person who made the call, if the game is over, that means that the person who made the call is the person who won, right? So then we push this into an instructions array, which is something that we then put into this outputs piece right here. Otherwise, if the game's not over, we we go to address 1, which is where the NFT exists. We have the current fen. So after the move up here, this chess object now can return a fen, which is the updated one of these strings. We continue the game state as in progress, and then we add the updated at. So in the future, in the next couple of weeks, I'm like thinking about introducing a speed chess version of it, right? Where it will allow people to, like, at a time limit, allow the system to then execute a random move on their behalf, just to keep the game going. And I mean, there's so much that you could do here, right? I mean, it's literally just a key value store. And yeah, so that's make move, and this is like really most of it. And then we have forfeit, which is if you want to give up, which, some people give up, not us. This will transfer all of the pot to the other person. Okay, cool. So this docs website, we've been, again, burning the midnight oil trying to get this stuff out. So excuse any of the spelling mistakes, but as you know, we're actively working on building, obviously, LASR, but then improving our docs. And so this has got a lot of information about pretty much everything with regards to LASR, a lot of the core concepts, creating an account, creating your first program, and then also you can come to chess, and this chess walkthrough is a good place to go to understand how to get this chess repo up and running. So let me just go ahead and grab that, github.com. And this is.
Rob, I don't think you're on the right screen.
Yeah, I was just going to say good flag in the chat. We can still see.
Oh,
are you showing your entire screen?
You haven't switched screens.
No. I was just grabbing the GitHub. There's the GitHub link for LASR chess. Okay, cool. So this is our docs website. It's docs.versatus.io, and it's very friendly and easy to read and easy to consume, and it has everything that you need in order to get up to speed, not only with chess, but also with Bird. Bird is effectively a Twitter clone. And we built a Twitter clone, and you can go and use it on our Playground website. It's playground.versatus, our Bird program. Oh, sorry, I'm in an incognito. But you come here and you can sign up. You have a username, a display name, and then a PFP URL, which at the moment you should just grab the URL from your Twitter account and copy that image URL to get a profile picture. And then another fun little thing that we have over here is because of how easy it is to build with LASR, I've effectively went and I created a lot of the same characteristics associated with Pokemon Red. And then so I'll bring this over here. Yeah. So these Pokemon are literally NFTs, and these Pokemon also have the ability to evolve, and you can literally train them. Oh, whoops.
And battle them.
You can train them and battle them. So the way that you level up and train these Pokemon, which are NFTs, is by battling against other people, and then when you win, each one of these NFTs or Pokemon NFTs, literally, it has all of the logic built into it for like the growth rate, and when you catch them, it generates a unique IVs for each one of the Pokemon. So no Pokemon is the same, and you guys might not know this, but every Pokemon, when you beat any one of these Pokemon, they have a certain EV yield, and the EV yield is split between 5 different characteristics, like attack, defense, speed, special attack, special defense, and so on. And so if you have Bulbasaur, which returns an EV yield of 1 speed, my Charmander, if I beat the Bulbasaur, then Charmander gets +1 EV speed, right? And then so as you're training these Pokemon, they're gathering EV points, which then allow for you to train Pokemon in a very specific manner. So if you wanted a really fast Squirtle, then you would look to fight people with a speed EV of 1, and so on. So this is just a really, really, really cool example of like how versatile and like easy it is to build with Laser. I mean, you can literally tap into all of the Web 2, and then yeah, I mean, it's boundless, the amount of possibilities. So yeah, what do you say? Should we dive into the surprise?
I think we should. Yeah. So for those of you that joined a little bit late, we discussed a little bit about what's coming for Versatus, and we are building a integrated cloud AVS for unstoppable applications. So what does that mean? A good sort of frame of reference, although imperfect, would be like a DigitalOcean on EigenLayer, completely censorship resistant and verifiable, but the ability to provision virtual private servers, SSH into them, download whatever you want to download, and point your domain name to them, all sorts of different things that you would be able to do in Web 2 that we just used to take for granted. As developers, building in the cloud, you'll now be able to do in Web 3 and inherit all the benefits, the crypto economic security of Ethereum, decentralization, censorship resistance, verifiability, etc. And we, as I hinted at, Hath didn't quite stay up all night. He's in Europe right now. So I stayed up to work with Hath literally all night to deliver this for you. It's a video recording of the very first successful attempt to deploy, to provision and deploy an app on top of what we call Allegra, which is our VPS product. And so, Hath, without further ado, you want to go ahead and play the video, and we can kind of walk them through what's happening. I know it's a little bit small, but basically we have a CLI tool that makes RPC calls out to a network of nodes, which can then provision virtual machines. Nodes form into quorums. They share that virtual machine amongst that quorum. And it does take a little time to actually spin up the VM instance, similar to what you would get with AWS or any other cloud provider, because you have to make sure that they're provisioned an IP address and everything else that goes along with it. And you have to, in our case, you also have to spread that across multiple nodes. So it does take a couple of minutes to spin up. But then once you spin it up, you can actually expose services on specific ports. You can put your public key into that instance. You can SSH into that instance, which you're seeing Hath here was doing earlier today. So he literally a couple hours ago SSHs into his instance. His instance has a unique content ID that's based on his signature when he first it's based on his address. So all this is tied to your Ethereum wallet. And then he's going to install, what are you installing here, Hath?
We're installing Node. Yeah, well, we're installing NVM, which is Node version.
So installing Node, installing Node.js, downloading his LASR chess game, the front end for it. And then what you'll see in a little bit is we're actually serving this front end from a random machine in the network. And so, we'll go to, right now we were hoping that we couldn't quite pull it off. We were hoping to actually be able to show like the domain name aspect of it as well. But it takes up to 24 hours to actually transfer the domain name. So we missed the mark on that by a little bit, but that is coming soon. You'll be able to point your domain names to it, prove your ownership of those domain names. You'll get a full cloud experience with the benefits of Web3. And so here he's installing all the dependencies for LASR chess, with npm install, and then he's going to build the LASR chess front end. He's going to run that Node.js server, right
now we're building the LASR program.
Oh,
so right the first thing we got to do.
Okay. So
yeah,
is deploying laser chess from this VPS instance as well, by the way. So when we say an integrated cloud, this is what we mean. You can build your smart contracts, your front end, your back end, all of it in one place. You don't have to go to 3, 4, 5 different providers. And we're going to make it even nicer. This is literally the first ever successful attempt at doing it. And we did this just a couple of hours ago, but we were so excited about it that we wanted to share it with you guys today and drop a little alpha on you. And we worked really, really hard to make this work in time. So, we're glad that you appreciate it and think that it's cool and nice, Alex and AJ. And in just a second here, you'll see. And all of this took, what did it take? You'd already built the chess game, so discounting for that. But it took maybe 18 minutes, 20 minutes max to migrate it to Allegra. So the process of going from a cloud provider to Allegra is seamless. You're going to use tools that you're already very, very familiar with. And all of this will be secured by EigenLayer's network of restakers and run on EigenLayer's network of node operators. The one piece that's missing from this particular demo is the AVS contract, where node operators can register and deregister from an AVS, and where they can, where they get paid and where they get slashed. Although EigenLayer hasn't quite rolled out payments and slashing yet. So right now it's just registration and deregistration. That will be coming hopefully by the end of next week. And then in about 2 weeks, we'll move this into a DevNet. So you'll be able to build smart contracts in any language, hook them up with your front ends and your back ends, running on a purely decentralized cloud. One of the cool aspects of Allegra that we think is really powerful, particularly for DeFi use cases in the state of the world as it is today, is that you'll be able to revoke ownership of your front ends and back ends and have them governed by a smart contract. And so now they're completely unstoppable. They're out of your hands. You eliminate a lot of the regulatory risk that exists in the US. So Allegra site is not live yet. This is just a internal demo. The docs, we're hoping to get out by end of next week. And then, as I said, roll out a DevNet in about 2.5 weeks. But the docs will hopefully go live. Minimal docs for now. This is a MVP version. We like to build stuff in public. So the first version of what you get with us is usually very minimal, but we like to improve it with the feedback of developers because we find that's how we're going to build the best product that developers actually want to use. And so here you see he's actually pulling up this site, the Laser Chess site, on just some random machine based on their IP address. He was able to acquire their IP address from the network. Now this will all be domain based, and you'll be able to just put in a domain name and get to the site and all of that. We just weren't able to quite pull that off in time, but we wanted to share with you anyways. And so here you go. AJ, you missed the original chess game where Hath beat himself very, very quickly. Hath, do you want to maybe just go over the chess game again for those that missed it earlier?
Yeah, 100%. So if you guys check out the Laser Chess repo, it's effectively there's two directories that's inside of the repo. One is the Laser directory and one's the app or web app directory. The Laser directory is just, it's got Laser Chess in it, and it has some test JSON. It allows you to test the program. We also, what we did earlier in this video is we built that program using Laser Control, which is our command line interface, and then we deployed it. We deployed it to Laser, and then after we did that, we got the program address that came back, and we put it into the env file inside the web app, along with the secret key of the person who is the deployer of said program, and then also the address for that person. And then we updated the environment file, we installed inside of the web app, and then we ran. And once we ran, we could literally play chess against one another. So yeah.
And one of the questions we often get, and for those of you that saw the earlier demo and saw this demo, is well, will this be as performant as cloud? And I think demos like this answer that, right? And so what's cool about the way that we build this is, again, it doesn't have the level of redundancy that a blockchain has. It's fundamentally not a blockchain. It's just a service. But you do get a lot of the benefits of blockchain. There is decentralization. It's a quorum-based model. We do erase your code, your instances, and distribute them like torrent style, so we can recover them in the event that the quorum responsible for your instances ever goes down, right? So it's still recoverable. And the nodes that are running this, right now they'll be primarily EigenLayer nodes, and probably forever as EigenLayer scales, they'll scale faster than we do likely. And hopefully we can bring some to the table as well. So, as that scales, we'll be able to scale out our network, and it scales horizontally. The more quorums we can form, the more applications we can host, and the more we can scale those applications. Our decentralized cloud is chain agnostic. It's not built like on a specific chain. It's fundamentally not a blockchain. Now, we do prove, we verify we verify the instances, and we prove the state of those instances on Ethereum, because that's how EigenLayer works.
Thank you very much. Do you guys have anything else to share? I see Gloria sharing lots of links in the chat, which is great.
Just spamming our Discord. Yeah, join our Discord. Follow us on Twitter. Reach out to Gloria if you have any questions, if you want to get involved, if you want to build on us. LASR is in a private DevNet that will be going to public DevNet pretty soon. So, we are we're shipping pretty rapidly, and we're hoping to get Allegra into a private DevNet, or a public DevNet by mid-June. So, you'll be able to build full stack applications in purely decentralized environment, early this summer. We would love to have you. We're also in the process. If you're already building an application, if your application is going to have a front end, if it's going to have off-chain components, we would absolutely love to. To have you building on us and to partner with you. We're looking for right now about 250 beta developers to come and build on Allegra, build on LASR, give us feedback, allow us to improve our product. And so hopefully we can form partnerships with a lot of you guys, bring you in. The last thing that I'll add, I've still got to work this out with Angela, but I'll just let everybody here know, we are doing a bounty. So if you do build something, if you do build a LASR program, which, if you join our Discord, we'll show you how to access it, even though it's still technically private. If you build a program on LASR, we're doing a bounty. It's $2,500. $1,500 will go to the best project, and then the rest of it will be spread out amongst the top 5. So please get in our Discord. Learn. I saw a lot of you guys are Python and JavaScript developers. JavaScript is now firmly in the lead at 43%. So get in there. You can build smart contracts in JavaScript. It'll take you maybe a day and a half to pick it up, and then you'll be off to the races.
Awesome.
And we have some ideas too. Like if you ideating in a new system is really, really hard. So if you want some ideas, joining the Discord, we'll throw some ideas at you of things we would love to see built, and we'll help you through it.
So where's the best place? You say you're looking for beta developers. Is there a best kind of path to join your Discord and reach out to you there? Where can people go to?
That's by far the best place. Yeah, it's by far the best place. And, our community it's decent size. It's not small, but it's not huge. And so as a result of that, you won't get lost. We'll be responsive to you. But we also have some super fans in there that, like, anybody who's building out, they would love to test your product out. They would love to give you feedback. They get really excited about people that are building on us. So get in there. You'll meet, Shroom and Bomb and Tins and, Kill and all of our kind of super fans in there. And you'll have a good time. It's a trip.
Awesome. You've managed to cram so much into 1 hour workshop. It's seriously impressive. We have the bounty, we had the sneak peek, we had some demos. So I think on behalf of everyone in the chat, there seems to be a lot of excitement. So thank you very much for joining us today and sharing that. As ever, the session will be recorded. So for anyone who missed the chess game at the start, don't worry, you can go back and watch it all. And that will be shared in our Hacker Pack very soon. So thank you all for joining us. Thank you very much to the Versatus team for coming along, giving the workshop, and looking forward to chatting to you all over on Discord.
Absolutely.
Cheers, everyone.
Thanks, guys. Take care. Have a great
Thanks,
Friday,
guys.
great weekend.